Hello everybody, this is a very important lesson. Here I will teach you how to prove that a quad is indeed cyclic. There's three ways how you can prove a quad is a cyclic quadrilateral. If we look at the first one, if AB, chord AB, subtends equal angles on the same side of AB, then ABCD are concyclic. And in other words, if you can show that angle D is equal to angle C, then ABCD is a cyclic quadrilateral. And then the reason is it's the converse of angles in the same segment. The second one is if you can prove that D plus B is equal to 180 degrees. In other words, if you can show that they are supplementary, then ABCD is a cyclic quad. And your reason, opposite angles quad supplementary. And then in the last one, if angle ABE, the exterior angle, is equal to D, then ABCD is a cyclic quad. Exterior angle equals interior opposite angle, then it's a cyclic quad. Now let me show you here on your cheat sheet. When you want to prove that a quad is cyclic, it's in fact you want to show that when angles in the same segment are equal, then it's a cyclic quadrilateral. Or if you can prove that this angle plus that angle, if they are supplementary, then it's a cyclic quad. Or if you can prove that the exterior angle of a normal quadrilateral is equal to the opposite interior angle, then your quadrilateral is cyclic. Example 1. In the diagram, AE is parallel to GF. BCH and ADG are straight lines between the parallel lines. BD and CG are joined such that D1 is 42 degrees, and I'm going to write that in, and B1 is 22 degrees, and G2 is 20 degrees. Number 1, calculate with reasons the size of H1. Now we can start by saying that H1 plus B1 is 180 degrees, and your reason co-interior angles supplementary. Why? Because FG is parallel to EA. We know that B1 is 22, that was given, so therefore we can calculate H1 and we find it's 158 degrees. Number 2. Prove with reasons that BCGD is a cyclic quad. So our aim here is if we can prove that C2 is equal to D2, then that is a cyclic quad. So we can start by saying that H2 is equal to B1, and your reason alternate angles is equal because FG is parallel to EA. Therefore, H2 is 22 degrees. Then H2 plus G2 plus C2 is 180 degrees, angles of a triangle. And we know that H2 is 22, G2 is 20 is given. We work out C2 and we find that C2 is 138 degrees. Then when we move down to D, we say that D1 plus D2 is 180 degrees, angles on a straight line. But we know that D1 is 42, so we can work out D2. We find that D2 is 138 degrees. And then we can see that D2 is equal to C2. They are both 138 degrees. Therefore, BCGD is a cyclic quad, and your reason, exterior angle is equal to opposite interior angle. Example 2. In the diagram, two circles ACBK and BKMT intersect at B and K. Angle ABT is 90 degrees. AKT, CKM, CAS and SMT are straight lines. Prove that BAST is a cyclic quadrilateral. We can start by saying that A1 is equal to K2. It's angles in the same segment, and it's because arc CB subtends them both. We can also say that K2 is equal to T1 plus T2. And the reason why you can say that is the exterior angle of cyclic quad BKMT is equal to the opposite interior angle. That's the yellow cyclic quad. And then you can see that both are equal to K2. So therefore we can say that A1 is equal to T1 plus T2, which in fact results in BAST is a cyclic quad because the exterior angle, which is A1, is equal to the opposite interior angle, which is angle T. In the next lesson, I will deal with tangents. Click on the video in the left-hand corner to take you straight to the next lesson.